Hello, and welcome to the Best Practices module. This module describes the various components of the QuickBase architecture at a high level and how they interact to create the QuickBase experience. We will also discuss designing for scale, how to measure and design for optimal QuickBase performance. Let's begin by taking a look at the basics of architecture. At the end of this lesson, you will be able to describe the various components of the QuickBase architecture, explain how these components interact to create the QuickBase experience, and describe the life of a QuickBase request. Now that we have that out of the way, let's talk about why you need to know this information. You might say, I just want to get right to learning how to build apps. Well, what we have found is that having an understanding of the back end of QuickBase will enable you to build high-performing apps that can be scaled over time, which can lead to increased services revenue for your firm. The scalability and performance of QuickBase applications is extremely important to QuickBase and our customers, and understanding what part our architecture plays in this will allow you to make good design decisions along the way, and this in turn will lead to better outcomes for your clients. So sit back and get excited to see behind the scenes of QuickBase. Let's begin with this overview of our architecture. This gives you a high-level sense of what QuickBase really is. As you can see, we have knit together a variety of web services, and at the center of this world, you can see the application servers that actually process each QuickBase request. And this is something that people really like about QuickBase. The fact that we provide an integrated set of reliable web services based around a core database engine, all under one consistent web UI. As you can see, this includes services such as email notifications, charting, and full-text search. All of these capabilities are built right into the QuickBase architecture. Without QuickBase, you would typically have to patch all of these services together on your own, but we have done that work for you, so you can get right to focusing on business problems for your clients. As you can see, we have the internet on the left side of the diagram that talks to redundant web servers. Those in turn talk to our application servers and then make use of a number of back-end services, which is something we'll go into a little more detail shortly. Everything we do on QuickBase is built with uptime in mind. We build out all of our infrastructure with redundant pairs. This means that from our network components to our storage and through to our CPUs, we have spare equipment at the ready to take over if something should fail. In the case of an extreme issue that impacts the wider data center footprint for an extended period of time, we also have a second fully equipped data center that we can utilize. And our operations team and network operations center constantly monitor the environments to ensure that the platform is performing well. We leverage both internal metric monitoring of the product and infrastructure, as well as outfitted external customer experience monitoring that actually runs predictable scripts that use the product via a web browser from various endpoints all over the internet and report status back to our teams. Now let's take another view of this architecture to break things down a little bit further. First, we have the two interfaces to QuickBase comprised of the native web UI, as well as the XML-based RESTful style API to access QuickBase programmatically. Moving down to the web layer, we see a set of load-balanced redundant web servers whose job is to manage the requests as they come in. Here the data is buffered from the internet and prepared for processing by our application servers. We then have our own custom load balancing technology that we have created here, and that distributes requests among a number of active application servers. These application servers run our proprietary in-memory database system, which handles the bulk of QuickBase requests. Finally, here at the bottom, we have a whole host of integrated services that the application servers can make use of. Next, let's follow what happens in a typical request. We start in the native web UI. This is where the user clicks on a link in QuickBase. That request is then passed on to one of our web servers, which then talks to our load balancer. The primary component here is called the MCP, which stands for the Master Control Process. The MCP is what assigns your particular application to a specific application server. Should we have an application server failure, the MCP is also what coordinates moving your apps to another available server. This process is extremely fast, as we typically make the routing decision in less than a millisecond for every request that comes in. Once the web server sends the requests onto a specific application server, the application server then executes the request. It will then talk to any number of the back-end services in the service layer should it need to gather more information to complete the request. It's also good to note that should the application fail for any reason, the system will pick that up and the MCP can then restart that process or take another automated action to correct the problem. Once the request has been completed, the app server sends the information back to the web server. Then it's transmitted out to the end user who initiated the request. Next, let's talk about the database engine that is behind QuickBase. We decided to build our own database engine primarily because we wanted to build it from the ground up for the web. We also wanted something that would be very fast and tuned to the size of applications that we tend to see with our customer workgroups that leverage QuickBase. We built this proprietary database with speed in mind and to reside in memory, which means we can complete most of our transactions without doing any disk I/O. This makes it much faster as we don't have to page in data and we don't have to do complicated storage algorithms on our back-end servers. QuickBase is also designed to be auto-tuning, which means that the system will cache data where it can. So sometimes if you have a formula field, for example, that calculates a value, we are able to cache that for quite a few requests. If you had a formula field that depends on the current time, for example, we might only be able to cache that value for the duration of the current request. QuickBase indexes the data as well, wherever there are opportunities to improve performance. As mentioned earlier, QuickBase has been designed for the web from the ground up. But what does that really mean? It's a multi-tenanted architecture, meaning we run multiple customers' applications in one server and one server process. We also do real-time load balancing, which is patented technology that is very, very efficient. We also designed QuickBase with security in mind right from the start, something we know that our customers really value. We have a very rich role-based permissions model where you can start with some standard permissions and add more as you tune your app to match specific business requirements. Within the code, we also have very consistent permission checking framework. QuickBase has a redundant architecture. If you're not familiar with redundancy, this means that we have a minimum of 2 copies of every hardware component. Network gear is all duplicated and any of our application servers are capable of hosting any QuickBase application. We also have 7x24 monitoring and management within the Intuit-owned data centers. We have made the system resilient, so even if there are multiple failures, we're able to return service quickly and continue processing. In most cases, the QuickBase architecture can self-heal, but when things get complicated, we also have a secondary data center built out exactly like our primary data center. We replicate data between sites every 10 minutes. If, for example, we lost access to our primary data center, the secondary geo-distributed data center can be activated to continue serving requests within 2 hours. Right now, we are running QuickBase out of our Las Vegas data center. The secondary site is in Quincy, Washington. This concludes our high-level overview of the QuickBase architecture. Intuit is sharing this level of information under MNDA and asks that you not share it directly with customers. You can always work with an account manager to ensure the appropriate info is relayed to the customer. This lesson is purely intended to give you the appropriate foundation to build structurally sound applications. At this point, you should feel comfortable describing the various components of the QuickBase system at a high level and understand how these components interact to create the QuickBase experience. You should now also be able to describe the life of a QuickBase request within the system.